In this unit, we're going to be looking at zeros of polynomials and graphing the polynomials, and it's a lot like what we just got done with quadratics. So if you remember, like when we had y equals, let's go with the factored form of a quadratic, x minus 3, x plus 2. So if we wanted the zeros or the x-intercepts, we'd set the y equal to 0, and then we would solve it, so we would get that our answers are 3 and negative 2. So what does that even mean? Well, those are the values if you plug it in. 3 minus 3, if you plug in a 3 to x, would get you 0 times 5, which is 0. So same thing with negative 2, also zeros out. And anyways, when you graph these, your zeros would be where it crosses the x-axis, and a parabola would only have 2. So what's going on in here? What we're going to have instead, if you remember, like this quadratic, this would be x squared minus x minus 6. That's a quadratic. Well, we're going to have more than just 2 zeros. We have 2 zeros because it's a power of 2, but what if we had like an x cubed there? Then we'd have an additional factor. Or if we had an x to the 4th, then we'd have a 4th factor possibly, and then we would have up to 4 zeros going on. And this can keep going on and on and on. So polynomials, we're going to be looking at something that has a bunch of different zeros and what's going on with the graph of that. So let's look at our first example down here, hopefully make a little more sense of what's going on. So we want to find all the zeros of this polynomial. They gave it to us in factored form, which is nice because it highlights the zeros. So what would the zeros be for this? Well, our zeros would be, the first one I could see right off the top of my head is this 3. Easy. Negative 1. What about that 2x minus 5? What are we going to do with that? So 2x minus 5, we can always just take it, set it equal to 0 and solve. And x equals 5 over 2. And there's one more 0 here. A lot of people miss this one. But up in front, if you see there's an x there. I'm never happy with the way I'm writing this 2 right now. Okay, so you see how there's an x here. That means that what would you plug into that x that would give you 0? Well, if you plug a 0 into that x, if you plug a 0 into this x, it would just zero everything out, which would be one of our zeros. The 4 has nothing to do with this. So if I were to write the polynomials 4 times x minus 3 is x plus 1 times 2x minus 5, that 4 does not cause a 0. It's the fact that there's an x in the front that causes that 0. So here's all our zeros. So we just got to plot them on this graph. So we have 0, we have 3, we have negative 1, and then the last one's 5 halves. Well, what is 5 halves? So 5 halves, rewritten as a mixed fraction. So 2 goes into 5 2 times, leaves us with 1. So 2.5 would be that last value.